Bismillahirrahmanirrahim. Most welcome to virtual session of week 12 of Database Management Systems course. If you can listen to me properly, please raise your hand. Okay, thank you. Let me share slides with you first. In this week, we are talking about enhanced database models. So far we have talked about different types of databases, and then we talked about different concurrency control techniques, recovery techniques. We talked about distributed databases. We talked about how we can implement security in databases. Now we are seeing some enhanced database models in which all these features are incorporated, and we'll be seeing how different types of databases are there. And we talked about temporal databases in our face-to-face class, and the topics which are left are about spatial databases and multimedia databases and the enhanced data models which are using these features. So what types of data can exist in these databases? So I'm going to continue from where I left. So if you can see the slides, you will see here that we are going to talk about spatial and multimedia databases. I hope you can see the slides properly. Okay. Now, spatial databases, as the name suggests, are concerned about the space or the places or physically distributed locations. The spatial databases means the database which is about the data which is located at different locations. These databases keep track of objects in a multi-dimensional space. For example, when we collect data from maps, it is spatial database. The geographical information system, which is containing information about different geographical locations, and about weather forecast applications or weather-related applications or databases. So because in the weather we'll be collecting data about different locations. In general, spatial databases are n-dimensional. This discussion is limited to only two-dimensional databases. Now, we are now talking about some spatial database concepts. The typical queries for spatial databases are these. The first is about range. It's called range query. It means finding objects of a particular type within a particular distance from a given location. So it means in a given location you are trying to locate or you are trying to find the distance between two locations. For example, if you use Google Map application and you tell a location on the map, and then you try to find your distance from that location, from your current location and that destination, that is obtained using the range query. The second type of query in the spatial database can be the nearest neighbor query. It means find objects of a particular type. Now, object can be anything. It can be an image, it can be a piece of information like a single variable, or it can be multiple objects. It can be text, it can be a number. So finding objects of a particular type that is nearest to the given location. For example, nearest Taco Bell from an address in Pleasanton, CA. So, and the third type of query is the special joins or overlays. Joins objects of two types based on some special condition. Like you are joining based on some condition. For example, intersecting, finding two objects which are intersecting or overlapping or within certain distance. For example, all Taco Bells within 2 miles from I-680. It means you are trying to find the different locations which are nearest to you, or you are trying to find the locations which are offering certain services. You are trying to find some data from different locations which are providing some facility or service or some piece of information. So you join, because you have to join two different formats of data to get the result. So that's why you write the special join or query. Now the R-trees is the technique used for special queries. And when we say R-trees, so you group objects close in spatial proximity on the same leaf nodes of a tree structured index. It means, because this is a method we use to group items, because you don't know that how many data items will be linked together. So what you do is that you make a node and you group the objects having commonalities with that node or having a common attribute to which you call index, and you connect all the nodes with that object. Internal nodes define areas, rectangles that cover all areas of rectangles in its subtree. So you're saying that when you say a node with its leaf, it means all the nodes in that tree, or all the nodes which are its leaves are having some common attribute. When we use for trees as well when you make special databases, when you divide subspaces in equal sized areas. Basically, the special data types and special data models used to collect special data. And when I say special data, it means the data located at different geographical locations. And the best example is the map data. Now the next type of database is the multimedia database. In the years ahead, multimedia information systems are expected to dominate our daily lives. Our houses will be wired for bandwidth to handle interactive multimedia applications. When I say multimedia application, it means that applications will be interactive. You will be giving inputs at runtime, and for example, you may be using a high definition TV or computer workstation, which will be having access to a large number of databases, including digital libraries, images, and video databases, which will be containing a large amount of multi-source multimedia content. For example, if you are interested in certain types of books, so the books will be downloaded for you, and you will be provided with the view of those books when you'll be in your house. You like certain types of programs on a TV, so when you enter the house, the TV will automatically start playing the TV shows or programs of your interest. And because your system will have access to, or your computer or your TV will have access to different forms of multimedia databases, so the images retrieving, videos won't be a problem. So the future is about multimedia databases, and we need to improve we need to have an efficient content management and content-based retrieval algorithms so that we can utilize the multimedia databases. When I say multimedia databases, it means I'm not only talking about text, I'm talking about videos, audios, images, and other forms of data. So what types of multimedia data is available in the current system? The data can be text, it can be formatted, or it can be unformatted. It can be parsed, it can be in any language, or it can be in any language, and it may also be required, like the content of your interest is available in some other language, so you need automatic translators to translate the messages according to your language and translate those contents and then present to you. It can be graphics, including drawings, illustrations that are encoded using some descriptive standards. So it can be graphics as well. Then it can be images, including photographs, encoded in standard formats such as bitmap, JPEG, or it can be contrast formats. It can be animations, now imagine, when you search for a particular image on Google, you type a word, and if the word brings you different images, and the word, because in Google image-based search is not possible, or is not much efficient. Like if I say that I see an object in an image, I want to search for that object from the image databases. It's not easy. First of all, I need to extract that object from that image, then I have to extract that object from all the images, and I have to perform matching. So searching and images, so when we perform search in Google, it is based on the labels which are placed along with the image. Like I name an image, if I name an image with some different word than the content it contains, so it will not be possible for me to search that image. And if I want to compare my image, that I want to see that how many images over the web are having similarity with my image, so I won't be able to find it. Or even if I place my photograph over the web, I want to find out that how many people have similar face with me, I won't be able to do it. Or even if an image, I want to find a particular type of object, so even if I want to perform the search of that image, that is not possible. So when I talk about multimedia databases, it means I need some efficient retrieval mechanism, I need some automatic analysis mechanism, I need some manual identification as well. So for different types of content, these things are required. Even if I talk about searching a particular audio, it's not possible right now. When I say, so the structured audio content should also be searchable. For example, I remember a sequence of some quotation or a tune of some music or some audio. So I want to search that whether so what type of audio, when I heard that audio and what type of audio it was. I remember its sequence, but I don't remember the exact words, but it's not possible so far. So we need to have some efficient mechanisms to do that as well. But this along the thing to be achieved after a long time. But right now we are only concerned about searching the audios which are well labeled. We are interested in searching the speeches. We are interested in searching different lectures. We are searching the phone messages, or we are searching different types of audio messages given at so different types of audio messages. We are also concerned about searching different video segments. So we need some efficient mechanisms to perform all these types of search. So even in the digital recordings or in the audio recordings, so we need to bring those multimedia data in the consistent format so that we can maintain multimedia databases. Or the multimedia data can be mixed multimedia data, a combination of multimedia data types such as audio and video, which may be physically mixed to yield a new storage format. The example can be like a PDF file which is also containing an image, or it can be like a Word file containing an image. Or if we talk about, let's say, WhatsApp communication, when we communicate on WhatsApp, we can send pictures, we can send text messages, we can send audio messages, or even we can make video calls. So if I talk about all the type of data that make a mixed multimedia data, so we need to have some databases to record that data as well. Multimedia data may be stored, delivered, and utilized in many different ways. Applications may be categorized based on their data management characteristics. So we need some applications to handle and store such multimedia data. Now, these are some very new fields, like automatic analysis of images is required Like we may be given an image and we may be asked that which contents or what is the shape of the image, what is the color of the image, what are the textures which you can find, what are the objects you can find in that image. So although we can find, but automatic analysis is not possible. Before talking about this, I want to give you an idea about something which are not over here. So the object recognition in images is a very important area. Then semantic tagging of images is important. Then analysis of audio data sources is important. So these things are important, and I would recommend that you read the relevant text about it from your textbook, because it's not available over here. In the slide it's not given, but the text is important and interesting. You'll find many ideas to work in future if you want to remain in the IT field in future and you want to pursue your higher studies as well. So this chapter will give you a lot of ideas or dimensions in which you can work. Now the other type of databases is the deductive databases. There are a lot of contents over here about deductive databases, but these all the contents are not included in your course. Slide 40 onwards is excluded. Just an introduction of this is important. Now, when I say deductive databases, it means the database is dependent on a language which is called declarative language. Declarative language is a language in which we don't specify that how we want to achieve it. We only specify what we want to achieve, because we declare that we want this. We don't specify that how to get this. Since we are specifying only that what we want or what we need, so we need some inference engine, which is called deduction machine. So what this deduction machine or which inference engine does is, it deduces new facts by interpreting the rules. It's used in deductive databases and it's closely related to the relational database model. It is also related to the field of logic programming and Prolog. So Prolog language is called the programming in logic. That's what we call Prolog, and which use backward chaining to evaluate that what that rule means. A variation of Prolog is called Datalog, which is used to define rules declaratively with an existing set of relations. Now, when I say that we are specifying, we are speciating, it means we specify facts and rules. The facts are similar to relation specification without the necessity of including attribute names. So we are not specifying the attribute names, we are just specifying the relation. And rules are similar to relational views, virtual relations that are not stored. From this slide onward, these contents are not included. We have excluded these contents from your course, but you can read it for your own understanding if you want. These are not in the learning objectives of this week, so we have excluded these contents. Okay, now I want to know if you have any questions from this chapter. This chapter is very interesting and it will be very helpful for you for future. I would recommend that you read this complete chapter and fill the context I have got in the slide over the weekend and come up with questions in our coming face-to-face class. And the next 2 weeks topics are also very important. That is about data mining and data warehousing. These are very advanced topics of databases. People are doing research in the area of data mining and data warehousing because these data mining and data warehousing areas will help you or will help us to implement multimedia databases and to improve our future or to provide our future needs or improve our future database applications. Okay, if you don't have any questions, so now I'm going to stop it over here. Okay, now I'm going to turn my microphone off, but I'm available over here. If you have any questions, you can type in the chat panel and I'll answer you over there. Okay? And there's only one assignment left in databases. That is the 6th assignment, which is about article review. And you'll be getting it by tomorrow, inshallah. Okay, well, thank you very much.